structure activity relationship, that is SAR of Parasympathomimetics. Parasympathomimetics means we will see the SAR of acetylcholine. So, necessity to design compounds that would serve as therapeutic alternative to acetylcholine results in structure activity relationship. That means how SAR of acetylcholine is discovered. That is because of our necessity to design compounds which are similar or alternative to acetylcholine, because we know acetylcholine has some limitations, so we want to discover some alternatives to acetylcholine. This is the structure of acetylcholine. For understanding the SAR, we will divide the structure of acetylcholine into three parts. First, we'll assign alpha and beta carbons. First part is quaternary ammonium group. Next part is CH2CH2 group, that is called as ethylene group. And third one is acyl of Z group. First, we will see the modification of quaternary ammonium group, that is NCH3 thrice. So first is replacement of the nitrogen atom by arsenic, phosphorus or sulfur atom results in less activity. This nitrogen is replaced by arsenic, phosphorus or sulfur. It gives less activity. From that, it is concluded that positively charged nitrogen atom is required for appreciable muscarinic activity. Next point is replacement of all the three methyl groups by ethyl groups result in cholinergic antagonistic activity. See here, replacement of all the three methyl groups on quaternary ammonium group by three ethyl groups result in antagonistic activity. Next point is replacement of all the three methyl groups by alkyl groups larger than the ethyl results in loss of activity. All the three methyl groups replaced by larger than ethyl means propyl, butyl, pentyl and so on, that results in loss of activity. Next point is replacement of any one methyl group by ethyl or propyl group result in much less activity than acetylcholine. So out of the three methyl groups, replacement of any one methyl group by ethyl or propyl group results in much less activity. Next is successive replacement of 1, 2 and 3 methyl groups by hydrogen results in successively decreasing the muscarinic activity. Successive replacement, that means if we replace one by one methyl groups by hydrogen, one methyl is replaced by hydrogen, two methyl groups are replaced by hydrogen, three methyl groups are replaced by hydrogen, so that activity is decreasing successively. Means from this compound has less activity, this compound has again less activity, and this compound is least active. Next is modification of ethylene groups, means CH2CH2 carbons. By increasing the length of ethylene chain, activity was rapidly reduced. Now this is CH2CH2. If we are increasing the length of it, means from CH2CH2, if we are doing CH2CH2CH2, means from ethylene it is propylene, then butylene, In this way, we are increasing the length of the ethylene chain. Activity was rapidly reduced, then propentylene and so on. This observation lead Ying to postulate his rule of 5. From this observation, the scientist Ying has given his rule of, what is rule of 5? There should not be more than 5 atoms between the nitrogen atom and terminal hydrogen atom for maximum muscarinic activity. Now, we understand by looking the structure of acetylcholine. I have shown the structure of acetylcholine in expanded view. Now, what does this rule say? There should not be more than 5 atoms between nitrogen atom and terminal hydrogen. So, nitrogen atom means this nitrogen atom. Terminal hydrogen atom means this is the terminal hydrogen atom, means end of the one. Between these two atoms, there should not be more than 5 atoms. Should not be more than 5. So these are 1, 2, 3, 4, 5 atoms. 5 atoms are perfect for maximum activity. If it is more than 5, then activity decreases. Next point, introduction of methyl group at alpha carbon of ethylene group results in alpha methyl acetylcholine. So at alpha carbon, if we are introducing methyl group, the new compound is discovered, that is alpha methyl acetylcholine. It has reduced activity at both muscarinic and nicotinic receptors than acetylcholine, but exhibit greater nicotinic receptor selectivity than muscarinic receptors. What does this sentence mean? It will understand. I am showing here muscarinic activity and nicotinic activity. Acetylcholine has equal muscarinic and nicotinic activity. Alpha methyl acetylcholine has reduced activity at both the receptors. Here it is reduced activity at both the receptors, but exhibit greater nicotinic receptor selectivity. Out of these two, nicotinic receptor selectivity is greater than muscarinic receptors. Now, next point is introduction of methyl group at beta carbon of ethylene group results in beta methyl acetylcholine, that is called as methacholine. Here, methyl group is introduced at beta carbon. It has muscarinic activity that is similar to that of acetylcholine, but has much less nicotinic effect than that of acetylcholine. So, we will understand this sentence. Again, we will understand by this graph. Acetylcholine has similar activity at both the receptors, while beta methyl acetylcholine methacholine has muscarinic activity almost equivalent. So muscarinic activity is similar to that of acetylcholine, but much less nicotinic effect than that of acetylcholine. So nicotinic effect is very less. So this compound becomes muscarinic selective agonist. Now in methacholine, by introducing the methyl group, this beta carbon now becomes chiral. So it's so stereochemistry, and muscarinic receptors display stereoselectivity. That means the one of the isomer of methacholine, that is S plus isomer, and another isomer is R minus methacholine. S plus methacholine is equivalent with acetylcholine, means it has similar activity that of acetylcholine, but R minus methacholine, so 20-fold less, means 20 times less activity than acetylcholine. Now the last part is modification of acyl group, that is CH3COO group, as would be predicted by the rule of 5 when acetyl group is replaced by its higher homologues, that is propionyl, butyryl, etc. The resulting compounds are less potent than acetylcholine. If acetyl group is replaced by propionyl group, and if it is replaced by butyryl group, that is CH3CH2CO group, CH3CH2CH2CO group, in both the case activity is less than acetylcholine. This is again based on the rule of 5. So I am showing here both the structures in expanded forms. Now based on the rule of 5, in both the structures between nitrogen and terminal hydrogens, the number of atoms are more than 5. 1, 2, 3, 4, 5, 6. Here it is 6. Here 1, 2, 3, 4, 5, 6 and 7. It is 7. So based on rule of 5, it should not be more than 5 atoms. Here in both the structures there are more than 5 atoms, so there is less activity. Next point is choline esters of aromatic or higher molecular weight acids possess cholinergic antagonistic activity. So acetylcholine is choline ester in that acetic acid group. This is, if it is here CH3CO, then it is called as acetic acid ester of choline. In that, instead of acetic acid, we have to replace aromatic or higher molecular weight acids. So if we are introducing here aromatic ring, that is called as choline esters of aromatic acids, and if we are introducing here bulky groups, that is called as choline ester of higher molecular weight acids. By bulky group, the molecular weight is increased. So in both the case, it gives antagonistic activity. Next point, replacement of methyl group of acetyl group by amino group results in carbamic acid ester of choline, that is called as carbachol. Means replacement of methyl group of acyl group by amino group. So now it is, instead of acetic acid ester, now it is carbamic acid ester, and it is given the name carbachol. It is equivalent with acetylcholine, both the muscarinic and nicotinic receptors. Equipotent means it is equally active, but is less readily hydrolyzed by gastric acid, acetylcholine esterase, or butyryl choline esterase than acetylcholine. So carbachol has similar activity to acetylcholine, but the main advantage is that it is less readily hydrolyzed. So the carbachol can given orally. The disadvantage with acetylcholine is that it is rapidly inactivated by this esterase enzyme and gastric acid, so acetylcholine cannot be given orally. Even acetylcholine cannot be given parenterally, but this carbachol compound can be given orally because it is less readily hydrolyzed because of the presence of amino group, so it can be administered orally. This same modification was then done in methacholine, which results in Bethanechol. Means in methacholine, same modification means the replacement of methyl by amino group. replacement of methyl by amino group. This gives Bethanechol. So Bethanechol is orally effective, potent muscarinic agonist with less nicotinic activity. Bethanechol has both the advantage, it has beta methyl group, so it has selective muscarinic agonist, and instead of methyl group here, it has amino group, so it is less readily hydrolyzed, so it is orally given and potent muscarinic agonist. So nicotinic side effects are less with Bethanechol. Next point, replacement of oxy group by sulfur reduces the activity. This oxy group, a replacement of oxy by sulfur reduces the activity. This is because involvement of oxy group in H bonding between drug and receptor. It suggests that oxygen atom is required to make hydrogen bond with receptor, while sulfur has less ability to form H bonding with the receptor. So thank you very much for watching this video. This is the SAR of acetylcholine.